Good morning, all. Am I audible to you? Am I audible to you?
Good morning, all. Am I audible to you? That's great. Now, good morning, all. Now, do we need to discuss the paper, or we should go to the next topic? Do you have any doubt regarding to paper? Do we need to discuss it? Okay, good. Okay. So let us discuss that quickly, and then we will go to the next topic. Um, okay. So first question was regarding to this token bucket, right? What is given to you? That is token bucket capacity C is given to you, right? The maximum output rate is also given to you. Which entity is this? What is symbolically what we call this? This is C. What we call this? The output rate, our maximum output rate. What is that? Yes, it is M, right? And this token arrival rate is rho. So what is the question to you? And length of the maximum burst in seconds is asked to you. That is S is asked to you, right? So the equation, you know that C is equal to ms minus rho s, and substituting the given values, you will get a value of S that will be capacity divided by M minus rho, and that will be 2.5 seconds. So answer will be 2.5 seconds. Okay. In pure aloha, vulnerable. What is a vulnerable time? How much it is? What is a vulnerable time in pure aloha? What do you think? What is the answer? Yes, it is 2 times frame. So it is 2 times frame transmission time. Okay. Now what is the next question? That aloha, pure aloha is given to you, right? The frame length in bits is given to you. Transmission rate is given to you, right? And what is given to you? That how many frames per second are transmitted is given to you. On an average, how many frames per second are transmitted is given to you. And what is the question to you? Throughput. Can you tell me what is the equation of throughput for pure aloha? Equation of throughput is, yes, it is g into e raised to minus 2g. Yes, it is. So now, if you want to find out g into e raised to minus 2g, only missing entity is g. So what you need to find out g. G is what? That number of frames, number of frames for per frame time. So first of all, you need to know that what is your frame time. Then you need to find out how many frames in that frame time are getting transmitted. Okay, so now how many? What is frame time? How will you find out frame time? So, what is frame time? That the time taken to transmit the one frame is the frame time, right? So, what is given to us? That frame length is 2000 bit, and we know that in one second is taken to transmit 2 megabits or 2 megabits in that channel. So, in 1 second, if we are in 1 second, if we are transmit 2 megabits, then in 2000 bit will get transmitted in how much time? That will be my frame time. So frame time, if you will see, it will be 1 millisecond, right? So, and what do I need to find out? So frame time I obtain is 1 millisecond. How it is obtained? That if in 1 second 2 megabits are getting transmitted, so how much? What is the time that I will take to transmit 2000 bit? That is one frame. How much time will I take to transmit one frame? Right. So it is 1 millisecond. So in one, so what I have, another information that I have, in 1 second I am having 1000 frames, and I want to know that in 1 millisecond how many frames I will transmit. So that will be in 1 second 1000 frames, in 1 millisecond one frame. So that will be my g. G is what? Number of frames per frame time. So and that g I substituted here, and I will obtain the value which is 0.135. Anyone having doubt here? Okay. Now, what is the next question? That shortest distance between A and C is, from the given link state packets. right? So link state packet gives information about the immediate neighbors. So what is the information that you are getting? That A has immediate neighbor B and D, and the cost to B is 6 and cost to D is 1. Same way, B has immediate neighbor A, C, D, and E. B has immediate neighbor A, C, D, and E, and the corresponding costs are 6, 5, 2, 2. 6522. Same way for the C, same way for the D, and same way for the E. If you will write, you will get this type of network topology, and you will see that minimum cost. Of course, ideally you should apply Dijkstra, but if you are not applying, that is not the question. That how whatever the method you want to apply to find out shortest path, that is okay. Right now it was not asked to have from any particular method, so you can choose your own way to find out shortest distance. And if you will see that shortest distance is 1, 1, and 5, that is 7. So answer is 7 here. So from this link state packet, you need to create network topology, and from the network topology, you can find out shortest distance by whichever method suits you. If it is link state packet algorithm, it will use Dijkstra. Is it clear to you? Up to this, everyone is clear? Yes or no? Great. Now, next question is, a subnet is using a link state algorithm, and it generates link state packet with a sequence number of 15-bit size. So it has a sequence number field of 15-bit size. That is what the meaning is, right? And if the packet is sent every second, how long would it take to wrap around before the wraparound occurs? What is wraparound? That actually 15 bits are used for the sequence number. So sequence number will vary from all zeros to all one. Wraparound is what after all ones, next sequence number will be 0000. So actually, after how many link state packets wraparound will take place. So if you will see that this number is 0 and this number will be of all 15 ones, that is 32,767. That, and totally those packets are 32,768 packets, right? So after generating this many packets, wraparound will take place. Now we need to know that in how much, what is the time that is taken to generate this many packets. That is the only thing that is remaining. So we know that after 32,768 packets, wraparound will take place, right? Why? Because we have assumed that, and it is given that starting sequence number is 0. So of course, from 0, it will take this many packets to take the wraparound. And what is additional information is given? The link state packet is sent every second, right? So in 1 second there will be one link state packet. So to send 32,768 packets, I will take this many the same seconds, 32,768 seconds, because in 1 second I am having one link state packet. So these many seconds will be the time, right? But the question is in terms of hours. So what you have to do, you have to take this many seconds and divide by 3600 will be that many hours. That this many seconds, you know that if this many are the second, how many minutes, and if these are the minutes, then how many hours. If you will convert the seconds into hours, you are going to get 9.10 hours as your answer. Is it clear to you? Now, okay, now what about, this is interesting one. Can you tell me the answer here? What is the problem with what is A correct? What are the steps of link state packets? Link state routing. First is what you have to discover. What you have to discover in the first step of link state. Are you covering all the networks in the router, or are you covering the neighbors only? Yes, neighbor. You have to discover the neighbors, not all the routers. That is what is the concern. So here, this is not true. It is not a feature of link state. It is not a feature. You are not going to identify all the routers, right? It is just discover the neighbor. Next step is that you have to measure the cost to the neighbors. So that step is correct. And third step is that information obtained in 2, that is in this 2 is you are going to send it across the subnet, right? You are going to send it and thus bypass the necessity of the shortest path algorithm. But no, after, if you are sending this link state packet into the network, you have to use the shortest path algorithm later on. That is what also we did here to find out the best route. So what are the valid one? This B and C are the valid one. and others are not. So answer is B and C only. Now next is in dash method. What is this? This is just a definition. In dash method, the station finds the line idle, and then if it is idle, then send it immediately. Otherwise, continuously sends the line, and continuously sends it till it becomes idle. So which method it is? Which method it is? No, no, it is one persistent. P persistence is what? That once you find idle, you will send it at with the probability of P. One persistent is what? You will send it with the probability 1. P is 1, that is, you will send it anyway. That is what? One persistent method. Yes, Prince, it is one persistent method. What next is? What is the next one? That the network is using CSMA-CD and has a bandwidth of 100 Mbps. If the maximum propagation time is 51.2 microsecond, what is the minimum size of the frame? What is minimum size of the frame? How much a frame must, how long the frame must be so that the collisions can be detected? What is in CSMA-CD in general? How long a frame must be so that collision can be detected? How long it should it be? I think this is covered in CSMA-CD, yes or no? How much time does it take to detect the collision? At least how much time? Yes, it is 2 time delay. Yes, it is 2 time delay. See, suppose I'm on this end, right? And what will happen? Like, I just a second. Let me know. Are you clear with this? Because this is this concept I'm going to need next in the next topic as well. Are you clear with why 2 times delay? It is okay that you forgot it, but are you clear with this? Otherwise, I can explain it now because it is useful in the next topic as well. But be quick, otherwise, I'm not going to explain it. Be quick. Are you clear or not? Are you clear that why it will be? Um, okay, let me tell you that suppose these are two stations, right? And this is A and D. Now what is happening? This is worst case we are taking. Like here it can be like B station, here it can be C station, but I am taking worst case scenario here, A and D. Right now, what will happen that A sends its packet. So now at this, I am considering this as my timeline. This is my timeline, right? So time progresses like this. So at this moment, my A sends a packet, or rather, I should, if you don't want to consider that entire frame, you can consider a beat even. That is your choice, right? That is okay. Something, one beat or some frame is transmitted here. So assume that on one frame is one beat is transmitted. Okay, so now it will take some time. After some, it will propagate in the channel. So at this moment, it will reach to B because it is a propagation time will be taken. So at this time, it will reach to B, right? Again, it will further move in the channel, and at this time, it will reach to C, and at this time, it will reach to D, right? So it will, at this moment it will reach to D. Assume that at this moment it reaches to D. So this is a propagation time that my beat has taken to reach, or my frame has taken to reach here. Now assume that collision happens here or somewhere here, very very near to okay, now let it be, let it be. Okay, now what happens that so can I say at this location, at this moment, uh, at this moment, at this time, my data is somewhere here. It is not at D. At this time, it is going to reach at D. At this time, at this location, it is not at D. At this time, D senses the channel. Right? At this time, D senses the channel. What will it find? What will be D's decision? Will it find the channel? And yes, it will be an empty channel. So at this moment, what will happen? At this moment, it starts transmitting. It's at this moment it starts transmitting. So whenever it transmits, will it only propagate in one direction in the channel? No, the entire channel, entire wire will get voltage. It will not be like in one direction from my station onwards I'm going to send the signal. My signal will go in both directions, right? And assume that this is the end, then only on this direction it will go. Suppose it is the end, then this will go in this direction. But if it is somewhere here, then it will go in both direction. Whenever signal is kept on the channel, it goes in on the entire wire. It is not like on one direction only it will go, right? So here it is going. So now what will happen, let me make it even a little bit more clear is by taking larger margin. um, so this will be more clearly visible to you. I'm taking this time. At this time, D is not aware that at this time D is not aware that A has transmitted. So now what D will do? It will sense and it will send its signal, and signal will go in this signal will what we can say. Signal will propagate in the channel and will reach to. It will also take some time to reach to all other stations. Like C will take at this moment, B will take at this moment, and A will take at this moment, right? So here it started transmission and it is unaware that A has transmitted. So now its signal is propagating, A signal is also propagating, and both will collide at this moment. Here the collision will take place. Now collision happens means what happens? What happens to signal of A? Actually what happens, collision happens, that means data corrupted, one becomes zero, voltage level changes. That is what correct. There will not be boom bam, we are not going to hear the noise. It will not be like that. What will happen, the data will get corrupted, right? So here the data will get corrupted, and how it will come to know, how A will come to know that my data is corrupted? How it knows? It senses again. Yes, so it continuously senses, right? So whenever this corrupted data which is changed here will also take some propagation time to reach A. It will also take some propagation time because here the data has changed. So when it is moving, it is in the channel, it will come back to A. It will take some propagation time. Yes or no? So at this location, A might come to know that okay, collision has happened. Okay, so how much time in worst case A will take? Like here, if it is here, it was collision happened, and hence it took this much time, right? Possibly D just started transmission at this moment, or just a moment before here. So it is possible that it will take even more time. How much time it will be? Suppose I say this is one propagation time. How much time this will be? We are taking worst case scenario that it just reached, and at that moment it returned back, and at that moment the corruption yes, it was the corruption occurred, and that came back. So it will be two time frame, two time frame. It is two time propagation delay. Generally it will not be frame time, it is propagation delay. Frame time is what, that this is just one bit is even transmitted, and then also this is going to happen. Yes, it is propagation delay. You are clear with the frame time and propagation delay are two different things. Are you clear with that, Jenny? Okay, so it will be two time propagation delay. Is it clear? So, so now what is the problem here, that in this implementation of CSMS CD, that it keeps frame with itself till it gets transmitted. Right. So if my frame size is smaller than such a way that it will take less than two time propagation time, what will happen? Till I will hear the collision, till time I would have transmitted my entire frame. And if I have transmitted my entire frame, I am not going to keep its backup. That is the problem with CSM and CD. We are not keeping backup. Once we transmit it, if collision has not occurred, that means I don't have to keep the backup. Right. So what happened actually, that I started A has say 3 bits to transmit. Of course 3 bits will take lesser time than two time propagation delay. Assume that whatever the frame length it has taken, that frame length is taking lesser time than this two time propagation delay. So now this 3 bit A has transmitted, and first bit collided here, and it came back after two time propagation delay. Till time, in that time already A has transmitted its entire frame, and it is not having any backup. How will it retransmit? It is the problem. So now what is the solution of the problem? That let us keep frame size at least such a way that you will, whenever you will hear the worst case propagation, worst case what we can say, um, in the worst case scenario, if you will hear the collision, then also you have some portion of your frame, so that you are not in the situation that you have entirely transmitted your frame. And second is, your sometimes what happens that if my if suppose that frame is smaller than this two time propagation delay, sometimes it is considered as a garbage, because suppose I have say 3000 bit frame, right? But collision occurs, so I will stop transmitting. So what will be the frame length, what will be the garbage length in the channel? It will be two time propagation delay, right? So if my frame is less than two time propagation delay, or it is or it is in that measure, generally it is considered as garbage. So that is also the case, but that is that's why generally we keep the frame size greater than two time propagation delay. Is it clear to you? Now, this concept I'm going to use in the next topic as well. I'm not going to revise it. Right? I hope you are aware about this. Any doubt in case you ask me, I'm not going to repeat this. Tell me any doubt in case you have. So, what should be minimum length? What should be minimum duration of a frame? You should select a frame length such a way that it should have minimum duration. How much? Repeat it so that I can be assured that you are clear with it. How much should it? Yes, it should be two time propagation delay. That's good. Good. So now fine. Now solve this quickly. Solve this quickly. So what is given to you? Bandwidth is given to you, and propagation time is given to you. So what should be the minimum size of the frame? So two time propagation delay. Actually, this is also wrong. I should not write I should write propagation delay. Yes, it should be two time propagation delay. So it should be this much, this many seconds. So in 1 second, if I'm transmitting 100 megabits, so in this many seconds, how many bits I will transmit? And this will be 10240 bits. And the question is in bytes, so I will convert this bits to bytes by dividing it to 8. So answer will be 1280. Now, next question. Are you clear with this? Now, any doubt in case you stop me and ask me. Now, next question is that again, this is limited contention protocol, or we can say adaptive tree walk protocol is there. And what is given to us that station 2, station 6, station 8, station 11, and station 15 are suddenly becoming ready at once, if you will see here, right? So, how many bit slots are needed to resolve the contention? So first of all, we will give chance in slot 0, we will give chance to this. So who will transmit? All the stations 2, 6, 8, 11, 15 will transmit. 2, 6, 8, 11, 15 all will transmit, and collision will take place. So in the slot number 1, that is in next slot, so we will give chance to this node. So who will transmit? 2, 6 and 8 will transmit here, right? And then also it is a collision, so the chance will be given to this one. So who will transmit? 2 will transmit, because there is no other station interested here. So station slot 2 will be this, and then slot 3, this will be given chance, because here no collisions, there was a successful transmission, so it is chances given to the sibling. So the 6 and 8 will transmit, collision happened, so go left first. So here we will go to this one, and 6 will transmit. And next, if we will go, we will go to here, because successful transmission give chance to siblings. So here slot number 5, 8 will transmit, right? Because it was successful transmission, give chance to sibling here. So it will be given to this. Who will transmit? 11 and 15. Then chance will be given. It will be a collision. So give chance to the child, and that will be slot 7 and 11 will transmit. Because it was a successful transmission, give chance to sibling, and you will get the chance. 15 will transmit, and this is how we will solve the contention. So slot number 0 to slot number 8, that is totally 9 slots we are taking to resolve the contention. So answer will be 9. What is jitter? Jitter is variation in packet arrival time. This is just a definition. It is variation in a packet arrival time. Okay, so that is fine. Which of the following statements are true in context of congestion control? So closed loop solutions attempt to solve problem by solving design, in essence, to make sure it does not occur in first place. once the system is up and running, mid-course corrections are not made. No, closed loop solutions made mid-course solution, mid-course corrections, and actually it is feedback-based system. So this is a definition of open loop, not a closed loop. A good algorithm avoids congestion by spreading the traffic. Of course, it is true. In explicit feedback algorithms, the source reduces the existence of congestion by making local observations such as time needed for acknowledgements to come back. No, it is implicit one. Explicit ones are using the packets. We need the at the source of congestion. We need. I mean, source of congestion should send the packets to inform the source about this congestion. In implicit, source should estimate from the available parameters. So this is again a definition. If the routers have infinite amount of memory, congestion get worse, not better. Of course, if you have infinite amount of memory, you will store all the packets, you will not discard any, and you will send them anyway, but that wait time of the TCP retransmission timer would have expired on the other end, and hence what will happen? Anyway, because already, because you have not received the acknowledgement in the given time, already source has generated new packets because of retransmission timer timeout, and new packets are also there in the channel. Old packets are also are in the channel, and hence congestion becomes worse. This is again the topic already discussed in the class. So these two are the answer in this question. What about the next question? That consider a LAN with 3 nodes N1, N2, and N3. The time divided into fixed slots, and node can begin its transmission only at the beginning of slot. So this is slotted aloha, right? A collision is said to have occurred if more than one node transmit in the time slot. This is the definition of collision. That is true. There's nothing. We don't have any new information in these statements. It is very well known facts. But here only thing that we have decided that this is actually slotted aloha. Now probability of generation of frame in a time slot by N1, N2 and N3 are 0.2, 0.4 and 0.4 respectively. Probability of sending frame in the first slot without any collision by any of these 3 stations is. So what we need to find out, probability of being successful, probability of sending the first slot. Probability of sending a frame in first slot without any collision, that means being successful, right? We have to find out at a time what is the probability that there will not be any collision. The probability, that means what, that at a time only one station is transmitting, then and only then collision will not be there. Okay, so what we need to find out that what is the probability that N1 transmits and N2 and N3 are not, or N2 is transmitting, N1 and N3 are not transmitting, or N3 is transmitting, but N1 and N2 are not transmitting, right? But what is the given information? See, in this slot, there is no collision. What is the meaning of that? That means only one station is transmitting. Who can transmit? N1 can also transmit, N2 can transmit, or N3 can transmit. But if N1 is transmitting, other 2 stations should not transmit. Okay, same way for N2 and N3. So how will you find out if N1 transmits and N2 is not transmitting and N3 is not transmitting? Or, I hope you are getting, so this equation is not difficult at all now, right? So what is the probability that N1 transmits? It is 0.2. What is the probability that N2 is not transmitting? Can you tell me what is the probability that N2 is not transmitting? Yes, it is 0.6. How have you calculated 0.6? 1 minus 0.4. Absolutely correct. So same way, 0.6 for N3 as well. True. And then this is OR, that we are discussing about this, that N2 is transmitting and N1 and N3 are not transmitting. In that way, if you will solve, you will get 0.456 as our answer. Okay, what is the given information here? Consider a subnet with this many routers, 3-level hierarchy is there. So what is the meaning? That's one, we have 8 clusters. We have 8 clusters, right? In that way, we have 8 clusters. In each cluster, we are having 18 regions. So we are having 18 regions inside, right? 18 regions we are having. And in each region, we are having 10 routers. right? So first of all, I will need 10 entries to cover my region, right? Then I have to cover other 17 regions to reach other 17 regions. So I will need 10 entries per plus 17 entries to cover my region. Once I have covered my region, I need to cover, as a router, I need to reach to this station, need to reach this region, I need to reach this region. In that way, I need to cover how many other regions? Totally 8 regions are there I have to cover, because already one region is covered, which is of mine. I have to cover the remaining 7. So in that way, the solution is 34. So in my total number of entries in my routing table is 34. Are you clear with this? This is also similar, just values are changed. This might have been discussed in the class. Are you clear with this? All the questions. Now I think it is regarding to UDP. So my portion is done. Are you comfortable with the paper? Any doubt? Any discussion you want to have? Okay. So now should we proceed to the next topic, our regular topic? Okay. So now what we discussed last time was regarding to limited contention protocols and other uh, protocols, and remaining things will be discussed by Sheetal madam. We are going to the next topic, which is Ethernet. What is Ethernet? Have you heard about Ethernet? What is Ethernet? What comes in your mind when you hear about Ethernet? Have you heard about Ethernet? What is Ethernet? Cable. Ethernet. Okay. What kind of cable comes in your mind when you think about Ethernet and others? What about what is Ethernet? Have you heard about Ethernet? First, tell me yes or no. Have you heard about Ethernet? Yes, sir. Yes. So Shinish says it is a local network, right? Yes. High speed data transfer. Ethernet gives you high speed data transfer. No, Chandresh. Here you are not a high speed. Currently, it might have upgraded, but Ethernet is not high speed data transfer, right? Yes, Junior, it is twisted pair cable, and yes, yes, Sainish, it will be what we can say, it is a local network. But now let me tell you what is Ethernet. Ethernet is a standard of developed by IEEE, provide internet connection. True, you are all of you. So now let me make it more clear to you. You all are having little bit idea. You are, none of you are correct here actually, but you are not wrong even, right? You are not correct here, fully correct, but even you are not. You should. We will have a broad definition in which the definition of all of you will be included, right? So you are, we can say you are partially correct, but it is but if we will go by that, what is Ethernet definition is like, it is giving us twisted pair cable connectivity, it gives us internet, everything is fine, but there are features, it is not Ethernet, right? Okay, let me tell you what is Ethernet. Ethernet is a standard provided by 802.3, IEEE 802.3. Now, like it is like RS-232, it is also standard. This is also standard, IEEE 802.3. Its other name is Ethernet. What it provides, it provides standard. What kind of standard it is? So it is standard for LAN. It is a standard for local area network. So here the point of signage comes. It is related to local network. It is related to a network which is formed in a room, right? Okay, so it is formed in a building or it is in a room. So this is actually LAN standard. Okay, so fine. Now in LAN, what kind of things do you think that should be standardized? If I have a LAN, what are the things I need to standardize? What should be, suppose I say it is, I am using Ethernet, that means you will be clear that these are the things that you might be using. Like in RS-232, if I say RS-232, you will say, okay, you are using start bit, you are using stop bit, you are using these are the voltage levels you are using. Then you are using parity, you might be using no parity, even parity or odd parity. But these are the things comes in your mind. Okay, if it is RS-232, this might be the things um, that we have, right? So that are standardized. Well, so whenever I say Ethernet, some things are standardized. Some points will be fixed. That they will be no need to mention them specifically, right? And they will be regarding to LAN. Can you tell me what are the things that can be regarding to LAN that can be standardized? Can you elaborate concurrency? What kind of concurrency you are talking about? Bandwidth, yes, it is true. Janil, I'm not clear with. Can you elaborate it? Yes, bandwidth is true. That how much bandwidth there will be provided. True. So one of the thing that will be bandwidth. Okay, so one of the thing will be bandwidth. Other things in a LAN, destination dest. I'm not clear with Priyank. Destination address, no. Destination address can vary. See, Ethernet is not like it is for my network only. In destination address, what is the standard? That means if you are using in your you are having a company, right, and you are saying I'm using Ethernet, I will understand. Okay, you are using, these are the things, right? And if I say I'm at the college, I'm at the college and my college is using Ethernet, then also you will understand. Okay, these are the specifications that you might be using. Your destination address will be different, right? In every case, it will be different, right? So this is not related to Naman. Here, Jenny says something like two users sending requests at the same time, then scheduling must be done. Okay, so again, see here what you are talking about. Switch. Okay, yes, you are like to avoid the collision, right? So can I say you are talking about how to handle multiple multiple senders, like to how to I mean how to handle multiple access. Can I say that is your point? Like two senders are sending, that means you are using the same medium, right? So yes, so which MAC layer protocol you are using? Can I say so? Like if in my network two senders are using the same cable, right? Because it is shared network, right? It is the same network. So if two users are trying to access the same one, um, which, yes, Nirav, you are also correct. I'm coming to your point. Which protocol should I use? Should I use CSMA? Should I use CSMCD? Should I use Aloha? Should I use which MAC layer protocol should I use? Right? And another thing as well, should I use switch? Should I use any other device? Right? So that I can avoid this type of things. I agree with Janet. True. Now operating frequency. So that, can I say it is bandwidth, Preet? You are talking. You are want to say this bandwidth only? You breathe. I think it is maximum operating frequency. That means how much bandwidth you are going to get, right? How much at 10 Mbps are you working, at 100 Mbps are you working, at 1000 Mbps? I mean 1 Gbps, whatever, right? So Nirav, yes, you are correct here that maximum length of cable which will give minimum data loss. Absolutely correct here. A very nice point. Suppose I am having two machines here connected in a room, right? I will connect them using a cable, right? How long I can keep my cable so that attenuation will take place in the cable, and still I will my next machine will detect it. So what should be the maximum length of the cable that I should keep so that the next machine definitely is going to hear that, even though the attenuation take place. So yes, maximum length of the cable, yes. And yes, Jenny, you are also correct here. What is that? Maximum number of nodes per cable. Like how many nodes in my network can a maximum number of machines that will share the medium, that many you can handle. Otherwise it will be too large to handle by this MAC protocol, or it will be too large to handle. It will be huge to handle, right? So yes, so these are the points. So now let us go with that. That is, you covered almost all the points here. So let me make it formal and clear so that everything will be clear to you. Now here, see, first of all, this is that one, that which type of cable. Suppose these are four versions of Ethernet. We had four versions of Ethernet. One is 10 base 5, 10 base 2, 10 base T, and 10 base F. What this 10 indicates? 10 indicates it gives 10 Mbps speed. It is 10 Mbps speed. So can I say bandwidth is covered? So whenever I say I am using Ethernet 10 base 5, you will understand that there will be data rate between my two computers which will be 10 Mbps. data rate of sharing is 10 mbps. You will say, but nowadays we are not satisfied, we are working with 100 mbps and all, so we are not using ethernet. No, you are using ethernet, but what we are talking about, we are talking about standard ethernet. Then after years after years, what happened that upgradation happened, and we are having the fast ethernet which works at 100 mbps speed, and we are having gigabit ethernet which works at 1 gbps speed as well, right? So it is not like we are not using ethernet, but we are using improved ethernet. But what we are talking about right now, we are talking about standard ethernet. We are not talking about its improvement right now. We are starting with the base only. Okay, so what it says, we are having 10 mbps speed. This 10 indicates 10 mbps speed. Okay, what about this base? What base indicates? It is a baseband communication. This, if you will see everywhere, there is a base. What is the meaning of that? It is a baseband communication. That means modulation or any other. It is just, as the signal is generated, it is transmitted in the raw form. It is not modulated, or it is not its frequency is not altered. As it is not broadband, it is not converted to higher frequency range. As it was generated and it was transmitted. That is base, right? It is not a broadband, but it is a baseband. What is the meaning of that? It is working at the raw frequency. Its frequency is not altered. Okay, so that is baseband communication. And what about this 5? What is this 5? 5 indicates that this. What should be the length of the cable that we were discussing now? What should be the maximum length of the cable? So that maximum length of the cable will be 500 meter. This 500 meter will be indicated here 5. Okay, so now if you will see 10 base 5, actually it was a standard which works at 10 mbps, and it was having a cable, whose maximum length was 500 meter. Which kind of cable was that? Was it twisted pair cable? No, it was a thick coaxial cable. It is possible that we are having a coaxial cable. We can connect to multiple computers using coaxial cable, right? So what will happen? There was a thick coaxial cable here. It was actually when it was used, it was yellow color one, and thick coaxial cable. You can think of the garden pipe. You've seen this garden hose. If you have seen, it is quite a thick, thick pipe, and in that we are having multiple computers connected with it, and in bus topology. Right, in a bus topology, we are having multiple computers connected with that coaxial cable, and that is how that. And what is the case? Like in that, this cable was thick coaxial cable. It was having marking at every 2.5 meter. At every 2.5 meter, there was a marking. There was a marking. There was a marking. What is the meaning of that? There you can connect your computer. At that marking, the minimum distance between two computers must be 2.5 meter. That is a standard. That is what is standardized, right? So, so that what will happen that okay. So this is so in 500 meter, you can connect your computers at least 2.5 meter away. How many maximum computers you can connect here? So that will be 100 computers per segment. In one segment, whose length is 500 meter, you can connect maximum 100 nodes. Okay, but that's why it is also known as thick Ethernet or thick coaxial cable Ethernet. But nowadays it is not used. Have you seen that type of Ethernet? No, you have not seen this type of Ethernet. Nowadays we are working with the advanced versions, so this is now not in use, right? Now next version was, after that the next version was 10 base 2. Can you tell me what will be the maximum segment size here? What is the maximum segment size here? What is the meaning of this 2? What is the maximum segment size? What do you think? What is the significance of 2 here? What was the significance of 5 here? The segment length was 500 meter. So what should be the significance here? What should be the segment size? Are you getting my question? Okay. It will be, yes, it will be maximum length of, yes, it will be 200 meter. True, it will be 200 meter. True. So Okay, so it will be 200 meter. So around 200 meter, but actually it is 185, but if you will see, it is rounded off to 200, so you can say that okay, it is of 200 meter. So maximum segment size is 200 meter. And how many nodes you can connect with that? It is 30. Okay. And what is the difference between this and this? Why that happened? Why this reduced? Why this reduced? Because it is not a thick coaxial cable, it is a thin coaxial cable. Right? Thin coaxial cable means what? That it will not have isolation, it will have lesser isolation here, and hence you cannot connect more computers there, you cannot have longer length there, so that because the what we can say that loss will take place, because we are having thin cable here, and hence what we can say lesser isolation, more loss, and hence you cannot go for the longer distance. But what is the advantage of this thin coaxial cable? What is the advantage of this thin coaxial cable? Whose flexibility will be higher, thick or thin? Whose flexibility will be higher? In thin cable you will have higher flexibility, right? So suppose you want to create this type of topology, and where you want to connect we can say that we are in a room, we are having this type of computers connected, and we want to pass our cable in this manner, and all the computers are connected here everywhere. In that way, if you want to have this type of topology, thin cable will be suitable. Thick, you cannot make this type of curvatures, or we cannot have this type of flexibility in thin. So what is this? This is actually cable topologies. This is one of the possible topology. Again, you can have as per requirement, but this is also possible topology. Another topology possible is what? That we are having suppose we are having multi-story building, right? So this is one floor. In one floor we are having thin coaxial cable, and we are having this or another type of topology on that floor. Then for every floor we are using thin coaxial cable, and according to our requirement we are having topology here, and all these floors are connected using a thick coaxial cable vertically. That is also possible. So it is not like only one cable you are using. You can use combination of multiple ones, right? So here you are using thin coaxial cable or this. And you can also have in you can have this type of topology as well. You can connect your cables in the tree manner. That is your choice. This is spine way, this is tree way, and this is we can say linear way or helical way, whatever you call, right? And this is how uh, different topologies you can form using this cable, that you can understand, right? It is not I mean, that depends on the application, and it depend on the requirement, how which type of topology you are using. So there's not big deal here. Here we don't use hub, because it is bus topology. In bus topology we don't use hub, we use hub in star topology, right? Okay, so that is fine. But now on what? So now the maximum segment is 200 meter. Here maximum segment is 500 meter. That means you can connect two computers at maximum distance 500 meter. Right? Sometimes we call LAN. Right now our requirement, or earlier even our requirement, was to connect computers in a room. Possibly room is a whole, right? It is a larger room. So in that it is possible that we need to go for the beyond 500 meter. So now what to do? So we need to have, suppose I have 500-meter cable here, right? And I want to connect one computer with this computer, or I want to create a LAN where two computers are, say, 1,000 meter away, right? So how, what I can do? I can have one more thick coaxial cable, right? And I can connect them using a repeater. What is repeater? Repeater is what? What is repeater? So what will happen? What is the problem with this? Why I cannot? Yes, it enhances the range, true. But how it is enhancing the range? So let us identify the problem. In 500 meter, what happens? Why it should be maximum 500 meter? What happens if I have larger cable? Yes, it regenerates the pulses. Actually, it is not amplifying genuine, it is regenerating one. Right? I'm explaining the difference between that amplifying and regenerating. Now tell me, suppose I have transmitted 1, 0, and 1. A has transmitted 1, 0, 1. What will happen up to this moment, because attenuation has taken place? So at this location, what will happen? I am drawing it here. At this location, it might have degraded and it has become like this, right? Now if I have further longer one, possibly this will be even get degraded, and and it will not be detectable. So that's why I cannot have longer one, right? Longer length I cannot have. So I have to keep repeater. What is the job of repeater? So what if you are saying amplifying? What amplification will, how amplification will happen? It will be like this. Whatever the shape is, na, that shape is only enhanced. This is amplification of this. What is regeneration? That I will detect it. This is one. This is zero. This is one, and I will regenerate them to one, 0, and 1. I hope you are getting the point. Jenny, regeneration and amplification. Right? So this is regenerating the pulses. Repeater is repeating the pulses. It is detecting and then regenerating. Right? So it will regenerate the pulses. Again, it can go for further 500 meter. So now I can connect two computers which are 1,000 meter away. But this standard limits this range even, that how many repeaters you can connect. You can connect at max 4 repeaters. At max you can connect 4 repeaters. Why you are why it is limited? Why it is limited? Because see, because of propagation time. Can I say, because this reads, it is regenerating, it will take some time, right? So now when, what is the propagation time between A and this X machine? So it will be that the propagation time on this cable, the processing time in the repeater, again propagation time here, right? And what is two time propagation delay? So it will be, again it will come back here, again it will get processed here, and again it will come back here. So that will be my two time propagation, which includes the repeater twice, repeater processing twice, right? So I have to keep my propagation time in limit, so that my two time propagation time will be in limit, so that my minimum frame size will be in limit. Otherwise I need to have a huge frame size. I cannot have huge frame size, na? Because if my two propagation time is huge, then I have to keep my frame size up to two time propagation time. So what is the limitation on this? How many repeaters you can use? At max, you can use 4 repeaters, so that your propagation time will be in limit, and hence two time propagation time will be in limit, and hence frame size will be in limit. So what is the indirect? I'm telling you which MAC layer protocol it is using. Ethernet is using which MAC layer protocol? What is your intuition from this? What is your idea from this? Yes, it is using CSMA-CD. MAC layer protocol that is used by Ethernet is CSMA-CD. Okay, so 4. So can you tell me what is the maximum length that is covered here? What is the maximum length using this thin and thick coaxial cable will be covered if I am using 4 repeaters? Maximum length between, will it be 2000? Calculate. 4 repeaters. Yes, it will be 2500, because see, I will need one repeater, then on both sides I will have. So in that way, if you will understand, it will be 5 segments you can connect using 4 repeaters. Yes, Jenny? Yes, it will be 2500. So 2.5 kilometers you can have between two machines. Right? Fine. So this is all about repeater. Right? This is all about repeater. Now we are going to the next case. Now one more point that we need to cover is yes, now we are having our machines that are connected with our thick coaxial cable, right? So here we need a connector, right? Whenever we connect our machine with our cable, we will need a connector. And if you remember, in coaxial cable there was a jacket, and then there was inside there was a copper wire. So whenever we are connecting our computers with that copper wire, uh, we need to have interface here, right? We need a clamp here which will connect my computer with this. So here we will need, if it is a thick coaxial cable, we will need a vampire clamp. What is the meaning of vampire clamp? It is actually having its meaning, right? Why it is called as vampire? Because actually you need to it is a thick one, na? So you have to pass through this jacket and all, and then you have to reach to the core till end. It is quite deep, right? And that's why we are calling it that clamps are vampire clamps, right? And So such clamps we are having, vampire taps, or we are saying we will say this vampire taps. So what it is actually, it is reaching, your computer is connected to the mid of your thick coaxial cable using vampire tap. This tapping is done using vampire tap. Okay, so now but and what about thin coaxial cable? In thin coaxial cable, the thickness will not be. Thin coaxial cable is the one that we have seen in our in what we can say in our TV and all, right? It is almost similar thickness, and if you will see that two cables are connected, if you will, if I want to connect two segments, right, or if I want to connect my computer here, where I will connect my computer here. This here will be my computer connected, and these are my cables connected. So this is what my BNC tapping. This is my BNC tap. Okay, and this type of tap I hope you have seen in your house as well, right? So right, so that BNC tapping is used. So here, if you will see that type of tapping here, this BNC tap, I hope you can see here. So this is comparatively here. This is very difficult to tap. I mean, difficult to connect here, but here it is comparatively very easy to connect your computers in the thin coaxial cable. Now, one more thing is that we, in our computer, we are having one circuit which adds its MAC address, right? And see, actually, data link layer. Now, what is the job? If you will observe, what is the job of the data link layer? Currently, so far, whatever you have studied, what is your conclusion? What will be your job of your data link layer? Here right now we are working on LAN. We are discussing about LAN, right? We are not working. We are not discussing outside network. Router and network layer we have already completed. Right now we are focusing on LAN, where my computers are physically connected with other computers, right? So that's why I'm discussing about LAN and data link layer. Okay. So in data link layer, what are the responsibilities of the data link layer? First of all, it will, one of them is it will add the checksum. Yes or no? Not compulsory, but definitely we are generally keeping the checksum. Are you agree with that? It is keeping the checksum. It will make a frame. It will make a frame, right? Framing it will be done. What is the other job? That it will add the MAC address of the MAC address. Yes, it will add the trailer. Trailer is only checksum, no? So MAC address, right? MAC address it will add of the source and of the destination. So these are the jobs. Okay. What is another job of the data link layer? So we can say it is because it is data link layer, but MAC is used. That means that it is a shared medium. A bus topology is used, and bus is shared among many. So what it has to do? It has to detect. It has to sense the collision. So it has to do CSMA. It has to sense the collisions, and it has to detect the collisions, and if the collision happens it has to retransmit, and all those things regarding to MAC it has to do, right? Now all these jobs of this are so if it is a thick coaxial cable, this tap is active. See, all these jobs are done by are done by this vampire tap, right? Not like all these jobs, but this CSMA CD part is done by this vampire tap. Not all, but the CSMA CD part is done by, that means here the tap itself, this tap itself is sensing, the tapping itself is sensing that collision has happened or not, collision has happened or not. That means here whatever the tap we are connecting, the tap must be able to detect the collision, sense the medium, and do provide the necessary signals to to this computer. Okay, so whenever we are having thick coaxial, when we are having the thick coaxial cable, this entire job of this data link layer is divided into two parts. This part is done by controller in the machine itself, and this part is done by transceiver that is kept. Transceiver is kept at the vampire tap. This is a transceiver which is additional extra circuitry which is kept at the vampire tap, and the controller and vampire tap is connected using transceiver cable, and or the drop cable, whatever you call, and this can be 50 meters apart. That will maximum length of this transceiver cable can be 50 meter according to the standard. Okay, so now I'm what is in thick coaxial cable? What happens? This entire job of this data link layer is divided into two parts. This part is done by controller circuitry in the machine, and this part is done by transceiver at the vampire tap. Okay, and how these two are connected using a transceiver cable, which is maximum length can be 50 meter. While if it is a thin coaxial cable, when the tapping is not done by vampire tap, it is just done by this BNC connector. At that time, the computer is responsible, which is in our case, right? In our computer is responsible for the controller itself is responsible for this all tasks. Controller itself is responsible for the all tasks. That means here this connector is passive. Connector is not responsible for anything, right? And when we are having additional connector here also we are having a connector, right? So whenever we are having a connector here, it can be twisted pair cable. Even this can be twisted pair cable. 50-meter drop cable can be a twisted pair cable, or twist and in that we are using 5 pairs of twisted pair cables. In that, one will be data in, another will be data out, right? One pair is used for data in, another pair is used for the data out. One pair is used for control in, next 4 pin is used for control out. And one pair not always used, but it might be used to provide the power to this transceiver circuit. Okay, so this is how these computers can be connected with the vampire tap. Okay, here this is basic. Next one is related to, so this is done, right? Now next one is related to uh, this 10 base T. What is 10 base T? It is also 10 base 10 Mbps baseband communication. T is for the twisted pair. So instead of thick coaxial cable, we are using twisted pair cable. Okay, and hence what we will use? We will use this type of hub. And this twisted pair cable can be connected with using here multiple twisted pair cables can be connected, and hence multiple machines can be connected using this hub, right? And how many machines you can connect with using one hub? So that will be 1024. And the maximum segment size, how far your segment can be from your hub, it is 100 or 200. Sometimes it is 100. If it is advanced level of twisted pair cable, you can have this length 200 meter as well. This length can be 200 meter as well if your twisted pair cable is of having it is higher category twisted pair cable if you are using, right? And next is 10 base F. It is actually it is 10 Mbps baseband fiber optic. That means now your cable is fiber optic, but still we are having 10 Mbps speed, right? So again it will need some hub or switch, and how many machines you can connect with that fiber optic hub. That will be different hub, but will be similar kind of central device, right? So how many machines you can connect? It will be 1024. And what can be the maximum segment size? That means how far you can connect your machine with the central hub. It will be 2000 meter, that is 2 kilometer itself. You can be far from your central hub, because it is fiber optic, loss will be very less. But you will say, if it is a fiber optics, why you are using 10 base? You can have 100 base, you can have 1000 base, right? Yes, if we are having fiber optics, we are not going to do with 10 Mbps. We can get much more better bandwidth. But actually, this standard was developed later, just to be compatible. Like right now we are having 1 Gbps, in that we are using fiber optics, but it is possible that certain systems are working on the older standards, so we have to have the backward compatibility, and for the backward compatibility this standard was developed, right? So actually when we are using 10 base F, that means it is for the backward compatibility. Otherwise, if we are developing a new one, we are going to use 1 Gbps speed if it is a fiber optic cable, right? So this is all about it. Now, one more point that is missing here is repeater. We have discussed. Only one point here is missing is time domain reflectometry. What is that? See, whenever we are using bus topology, if you remember that in bus topology, we at the end we are having we at the end we are keeping terminators. If in the bus topology we keep the terminators at the end. If you have ever heard, if you have ever read about it, right? So why we are keeping terminators? Because what happens that whenever A sends signal to say machine B here, right? So what it will do, it will put its signal here and it will get propagated here. Okay, so if we are not keeping any terminator, terminator absorbs the signal actually. It absorbs the signal. So what happens if my signal will get propagated to the end and it will get absorbed here, right? And no issues are there. But suppose I am not keeping them, then that will be open end of my cable. From the open end, signal has tendency to reflect back, right? From the open end, it reflects back, and what will happen? My signal will collide with myself, and this is going to create the trouble. That's why I need to keep terminators in the bus topology, right? Now suppose I have kept my terminals, I have kept my terminals properly, but now cable gets broken. It gets broken somewhere here, right? It becomes broken, means what? It becomes open here. So now what will happen? If I send my signal here, it will get reflected back here, right? So this characteristic is generally used for detecting the cable breaks, right? Suppose I doubt that there is a cable break. What I will do, I will send my signal, I will note down the time, I will and then what will happen? According to the tendency, it will come back, and I will notice my collision at this moment, and I will come to know that I will note down that time too, and then I will note the speed even, right? I will note the speed of propagation speed even. Then I will come to know that what is my speed in, it is this x meters per second, and my time that I have noted down is say 10 seconds. In 10 seconds it came back. That means at 5 seconds it must have taken to reach here. So if in 1 second it goes by this many meters, in 5 seconds how many meters it would have traveled, according to that I will be able to judge the cable break. So this entire thing is known as time domain reflectometry, and generally it is used for the bus topologies, and which makes very difficult thing, and to detect cable breaks will be very difficult in this. Why? It is very much easy in case of hubs, and in case of when we are having central device, so it becomes very easy. That's why also we are this topology, that star topology in Ethernet has become popular because of this type of advantages. So we can say it is more popular version of this Ethernet is star topology compared to bus. I'm not saying bus is not used, it is used, but it has to use this type of complicated methods to detect the cable breaks and problems. So generally we prefer this type of bus, and I mean this star topology. So this is all about Ethernet cabling. Any doubt in case you have, you can ask. In the next topic, in the next lecture, we will discuss more about this 802.3. Of course, it is remaining to discuss yet. Any doubts so far? Okay, so we will meet in the laboratory. For now, you may leave.